Hey all, I just wanted to give you a quick recap of today's lesson because we talked about a lot of stuff. And today's learning target and success criteria are particularly important because you are doing a LESA for today's asynchronous work. On this standard, develop models and to describe the atomic composition of simple molecules and extended structures. And we've been talking about polymers, and polymers are a type of extended structure. And we can see that because we've got this really long chain. So this is the molecular model kit version, and each end has an open bonding site in it, which means that this polymer chain of monomers stuck together is an extended structure, okay? So that's how we are going to be reaching this standard and assessing this standard. I asked you to draw an extended structure, or excuse me, I asked you to draw a polymer using a shape to represent a single monomer. And this was one of the awesome student examples I got so I asked you to use this shape to represent a monomer. So each of these was a monomer, and that's what they labeled down here. They used a key, and then the whole thing they labeled as a polymer. So a polymer is just a really long chain, and this person curved it around. It could have been straight, could have been wobbly, okay? Either of those would have been acceptable. Then they color coded and made the bonds red. So the bonds are the things that link those polymer chunks, those monomers together, okay? So if this is a monomer, now we've got multiples of them. That means this is a polymer, okay? Today's activity, we used paper clips to represent a monomer. So a single paper clip represented a monomer, and then we were able to use a chain of paper clips to represent a polymer. And then we linked those chains together, and this looks like just a giant, and it fell apart. So you're going to watch the procedure videos if you need to, and those are linked on the Canvas page. Part A is about modeling the monomer, B is about the polymer, C is about the cross-linked polymer. And the important thing that I want to point out in just a second is the relationship between what we did today with modeling with what we did on Friday when we watched the video about actually making the slime, the new substance. So here's the data table that we filled in using the procedures videos, which again are linked on Canvas. And you can see that we used a single paper clip to represent a monomer, the chain of paper clips to represent the polymer, and the linked chains of paper clips to represent that cross-linked polymer, okay? So we saw the changing in properties based on our model. And the important thing to realize is that our model did represent those properties that we actually saw in activity 11, which was on Friday. So here I've labeled this one as the PVA was the polymer, and we saw that the polymer was pourable, stirrable, not sticky, not bouncy. So if we go over here and look at the polymer, it was fairly easy to pour. Our model was fairly easy to pour. It was sort of stirrable, so there are some limitations to our models. And when they grabbed one monomer, several monomers were attached, but not very many, okay? So some of them were attached, but not a whole lot of them, okay? It's not like the whole thing came out. Then the cross-linked polymer was very hard to pour. Some moved separately, but most of them stayed in a big chunk. And when she grabbed one, only 2 or 3 were left behind in the cup. The rest of them were all pulled out at one time. And it was sometimes hard to grab just one. Compare that to the properties we observed on Friday of the slime, which was our final substance. It was not pourable. It was not very stirrable. It was sticky and it was bouncy. So this stickiness can be related to the pulling of the activity 12 observation. So it's important that you understand the connection between the model showing us the properties and the properties we actually observed when we made this substance in the lab video, okay? So the last thing I want to do is I want to kind of connect the dots with the model I told you to draw at the beginning, or a model I asked you to, and what you're being asked to do for the LESA for today, okay? So if we had the monomers as just kind of a random shape, okay? And you can choose whatever you want. So this is a monomer, okay? And I can choose a different color to bond it together. Ignore my email notification down there. Okay, so, but then I need another set of monomers because eventually I need to draw a cross-linked polymer. Okay, so right now I've got 2 chains. Okay, so that single thing right there is a monomer. This right here is a polymer. Now we need to add in the chain, the things that link them together. So I'm going to change my shape and my color, and I'm going to add in this little thing right here, and I'm going to call this the cross link. And it is a molecule, okay? The monomer is also a molecule. Okay, so the monomer is also a molecule. But then I can label this entire thing right here. This entire thing right here is the cross-linked polymer. Okay, so in the draw it for the for the presentation today, I only asked you to draw a polymer, which was this single chain. Then we use the paper clips to make and model a cross-linked polymer. This is what a model of the slime from Friday could have been. Okay, so it was not pourable. It moved as a big clump. It stuck to the paper towel. It was sticky. This is an example of a model of what a cross-linked polymer could look like. Okay, so this can help you with your LESA. Make sure you read all the parts of your LESA, okay? So good luck.